Thank you very much. I am Hussein Abdurazak, popularly known as Ninja Man. Now let's have a look at ellipse. What an ellipse is. It is also part of the conic section. Ellipse is a set of points that is whose sum are equidistant from two fixed points, and those fixed points are called foci. Foci because they are plural. If you have watched my previous video on parabola, you understand what is focus and directrix. So let's have a look at ellipse, which in fact is a set of points whose sum is equal to a constant, and the constant is 2a. The set of points whose sum from two fixed points is equal to a constant. So if you have this, but this is a curve. On conic section, this is a curve. If you have a variable point xy, a variable point xy here, and this line, let's take this line as x-axis. This is the x-axis. The x-axis from one point to the other point, the vertex is called major axis. Major axis. And the major axis, the distance is 2a. And the y-axis is a minor. From this point to this point is a minor axis. The minor axis, the distance is also 2b. But 2a is greater than 2b, and therefore b is greater than a. So if you have a point here, this is the center. From this distance to this distance is equal to the distance here to the distance here. So if here is f1, from the center to f1 is equal to the center to f2. And if you have the x-axis, the value of c here, let me make here c. And the point here, the y coordinate there will be 0 because it is on the y axis. The y coordinate, it is on the x axis. On the x axis, y is 0. So the y coordinate there will be 0. And since it is in the opposite side, if you have 4 units here, the opposite side will be negative 4. So if here is c, the f2 here will be negative c, 0, because it is on the major axis, which is the y axis, the major axis. Now, the definition of ellipse is that the distance pf1 plus the distance pf2 must be equals to 2a, the whole distance, which is on the major axis. Now, so the distance pf1 plus the distance pf2 should be equal to 2a, which is a constant. Now, how do you derive the general formula for an ellipse? That is our focus. So with this, we use the distance formula for distance pf, which will give square root of x plus c squared plus y minus 0 all squared will give us y squared plus distance pf2, which will be x square root of x1 minus x2, x minus c all squared plus y squared. That is y minus 0 all squared will give us y squared. Is equal to 2a. This is the condition for ellipse to exist. It is a set of points, in fact, variable points. P can be on any point. P could be any point on the curve. In fact, this is a curve. And the distance from P to the focus, to the foci, F1 and F2 must be equal to the constant, which I have done. Now, to solve this, I will send this one just like I'm solving rational equations. So it will be x plus c squared plus y squared is equal to 2a minus square root of x minus c squared plus y squared. Now, what I have to do is that I have to square both sides. Squaring both sides this way, squaring here. Now the square root will be out. Left with expansion of inside will be x squared plus 2xc plus c squared. That is for expansion of, because the square root will be out. Now I'm expanding what is inside. Plus y squared is equal to, you square this one will give us 4a squared minus 2a times the whole thing will give us 2a square root of x minus c squared plus y squared. Then plus the square of all these things, which will move the square root to give me x minus c squared plus y squared. Now I will expand this one. For the meantime, this is equal to sign. So that I will get x squared plus 2xc plus c squared plus y squared is equal to 4a squared minus 2a root x minus c all squared plus y squared plus expanding this one, you get x squared minus 2xc plus c squared plus y squared. Good. Now, if you have it this way, this is positive y squared. On the other side, we'll cancel positive y squared here. We have positive c squared, we'll cancel positive c squared here. Now, here we have x squared minus 2xc plus c squared. And here is also positive. So that if this one comes here, it will be negative. X squared here will cancel x squared. So negative 2xc plus this 2xc will give us 4xc. We get 4xc is equal to 4a squared, minus 2a this here should give me 4a. Here should be 4a minus 4a square root of x minus c all squared plus y squared. This is what we have. Now if you divide through by 4, you will get xc is equal to a squared minus a root x minus c all squared plus y squared. This is what we have. Now, I can bring minus a root x minus c squared plus y squared to this side to make it positive. So that I will have a root x minus c squared plus y squared is equal to a squared minus xc. Now, I will finally square both sides. I will square both sides. I will square this side. This one gives me a squared multiplying, because the square affects the a squared multiplying the expansion of inside one, the inside one will give me x minus c squared plus y squared is equal to a to the power 4 minus 2a squared xc plus c squared x squared. The expansion of this is a square of binomials, and when you expand it, this is what you get. Then a squared here will multiply. Expanding this will give us x squared minus 2xc plus c squared plus y squared, which is equal to a to the power 4 minus 2a squared xc plus c squared x squared. As for this one, nothing has been done to that side. Now, I will distribute a to the power 4 throughout. A to the power 2 here. Throughout. We get a squared x squared minus 2a squared xc plus a squared c squared plus a squared y squared by distributing a squared throughout is equal to a to the power 4 minus 2a squared xc plus c squared x squared. Now you look at the left hand side, the right hand side and the left hand side, you compare. You see that we have negative 2a squared xc. We have negative 2a squared xc. So this one will cancel this side. Now, good. We have a squared x squared minus, I will bring c squared x squared because x squared is there. C squared x squared plus a squared y squared, which is equal to a to the power 4 minus a squared c squared. Good. Now, this one I can factorize x squared out to have x squared out, a squared minus c squared plus a squared y squared is equal to, factorizing a squared out here, I will get a squared minus c squared. For this one, when you multiply, you still get back. So I will divide through by a squared out, a squared minus c squared. Each of the terms, because there's addition here, I will divide this one by a squared out, a squared minus c squared. This one, to whole thing by a squared out, a squared minus c squared. So that this one cancels this. We have one here. Now, a squared minus c squared will cancel this one. Good. So that here we shall have s squared over a squared. Then plus, in fact, this a squared will cancel this a squared. So we have y squared. All divided by c squared minus a squared minus c squared. A squared minus c squared is equal to 1. Good. Now, because here everything is squared. If you let b squared is equal to a squared minus c squared, then the whole of this turn out to be x squared over a squared plus y squared. Whatever you see, a squared minus c squared, you put b squared there. 2 over b squared is equal to 1. And this one is the formula for the equation of an ellipse with the center at the origin. This is the equation that you need to know. And we shall apply this. And subsequently, we shall deal with an ellipse without the center being at the origin. So this one, the center is at the origin. Now let's look at something significant here. If a squared is equal to b squared. In that case, you see that you get x squared over a squared plus y squared over a squared. So if you multiply through by a, you will get x squared plus y squared is equal to a squared. The situation whereby a squared is equal to b squared. And therefore, if a squared is equal to r squared, you see that we get x squared plus y squared is equal to r squared. And this one, this beautiful formula is also equation of a circle whose center is at the origin. In that case, you see the relationship between a circle and an ellipse. So let's have an example on how to solve for ellipse. In fact, if you get this, A is always greater than B. So if A is greater than B, then it means that the foci, in this case, if A is greater than B, A is greater than B, in this case, the foci is on the major axis, that's on the x-axis. But the situation whereby you have this, x squared over b squared plus y squared over a squared is equal to 1. This one, the foci will be on the y-axis because a squared, A is greater than B. You know the value here is greater than the value here. For example, if you have x squared over 16 plus y squared over 9 is equal to 1. Then the foci will be on the major axis, the x-axis. The situation whereby you have x squared over 9 plus 16 over y squared over 16 is equal to 1. You see that this one, if you draw this, it will be somewhere like this. And the foci will be around this side. But the other way around, it will turn. This one will turn like this to the y-axis. So you should know how these things are done. For instance, let's draw this. Let's sketch quickly on this. Let's sketch this. If you have x squared over 16 plus y squared over 9 is equal to 1. This one, you compare to the general formula. We have what is x squared over a squared plus b squared y squared over b squared is equal to 1. So now you see that a squared is equal to 16 and you get a to be plus or minus 4. And b squared is equal to 9 and you get b to be equal to plus or minus 3. The other way also that if you want to sketch this on x-axis, what happened to y? Y becomes 0. So the whole of this one becomes 0. So that you will have on y-axis, you will get on x-axis, you will get y is equal to 0. So that this one will be 0. And you will get x squared is equal to 16. Because x squared over 16 is equal to 1. You get x squared is equal to 16. You get x is equal to plus or minus 4. So you get 4, 0, negative 4, 0. Now, then you go to the y-axis. Y-axis, then x is also equal to 0. When x is equal to 0, meaning that this whole part becomes 0. So that we have y squared over 9 is equal to y squared over 9 is equal to 1. You get y squared is equal to 9. Then y is equal to plus or minus 3. So you get 0, 3, 0, negative 3. This is for the y. and this for the x. Now, how do you get your foci? The foci, what I derive here, you see b squared is equal to a squared minus c squared. So b squared is equal to a squared minus c squared. And you get b is equal to square root of a squared, what is 16 minus 9. 16 minus 9 will give us 7. Not so? Because 9 plus 7 will give us 16. Yes. So this will get root 7. So in that case, plus or minus root 7. So the foci will give us plus or minus root 7. So now I will draw my x and y axis to draw this one. X 40. So 40 will be here. Negative 40. Then y 03. Because you see that the distance is less than the one, so this one will come small. 03. Negative 0, negative 3. Then the fourth side, root 7 will give us probably 2 point something, so root 7. So negative root 7. No, here is positive s axis 0. And the same distance here, negative root 7, 0. This f1, f2. And it will pass through. And this is your beautiful ellipse for this. And that's how we have drawn it. Thank you very much. Watch me on Ninja Easy Mathematics for those whose centers do not fall at the origin. From there you come and meet me with hyperbola. Thank you very much.